Hello and welcome to excelmasterseries.com. Today we're going to show how to determine whether the click-through rate in a pay-per-click ad campaign within an ad group was affected by the headlines, the ad text, or the interaction between the two, and we're going to use two-factor ANOVA with replication in Excel. Now, ANOVA stands for Analysis of Variance, and ANOVA is a test to determine whether three or more different treatments or methods had the same effect on a population. ANOVA tests the null hypothesis, and the null hypothesis states that varying that factor or treatment has no effect on the output. And the three different types of built-in ANOVA in Excel are single-factor ANOVA, two-factor ANOVA without replication, and two-factor ANOVA with replication, and that's what we're going to use today, two-factor ANOVA with replication. So let's take a closer look at each one of those types of ANOVA. Single-factor ANOVA simply tests one factor. That factor has a null hypothesis which states that varying that factor has no effect on the outcome. Two-factor ANOVA without replication just adds one more factor into the test. Each one of those factors has its own separate null hypothesis stating that varying that factor had no effect on the outcome. And finally, two-factor ANOVA with replication. It's the same test as the previous, except we're going to replicate the test in two different locations so we can compare the interaction between the two factors. So each one of those two factors will have its own null hypothesis stating that varying the factor doesn't affect the outcome, and the interaction will have its null hypothesis stating that varying the interaction does not affect the outcome either. So let's take a look at the test that we're going to run right now. A company's running a pay-per-click advertising campaign on both Google AdWords and at Yahoo, and the marketing manager wants to test whether the headlines and the ad text and the interaction between those two have any effect on the click-through rate. So the manager creates three different sets of headlines and three different sets of ad text within one ad group. So there are 9 possible combinations of ad text and headline. Then the manager runs all 9 combinations just about an equal number of times on Google AdWords and Yahoo over about 2 weeks. And below is the click-through rate for each one of those combinations. So we can see, for example, 2.8, that would represent the click-through rate for a combination of headline 1, ad text 1, run on Google AdWords. That means for every 100 impressions of the ad, 2.8 people clicked on it. That's how to interpret that. And this is the way the data must be inserted for this ANOVA in Excel. So let's run the ANOVA right now. Click on Tools, and then scroll all the way down to Data Analysis. Sorry you can't really see it there, but that's the last choice. Data Analysis tool. And here's a dialog box. Select ANOVA two-factor with replication. Hit OK. And now we're going to select the input range, and that would be everything colored in yellow. And the data must be inserted just like that to run this test. Next, we're going to hit number of rows per sample, and we're running each test on Google and on Yahoo, so that would be 2 rows per sample. And the next piece of data is the alpha. Alpha is minus confidence level. We require 95% confidence level in this test, so the alpha is going to be 0.5. The output range would be simply the cell that will be the upper left-hand corner of where the output will start. Now hit OK and run the ANOVA test. And here's the output, starting right there. Let's take a closer look at it. Here's part of the output. And if we scroll down to see the second part, the p-values at the bottom, that is the most important thing that we're looking for. Now I've color-coded the output to make it a little bit easier to read, and we can see headlines are the columns and the ad text are the rows. And I've color-coded this. There's a general rule that we need to follow. If the p-value is less than the alpha, alpha is 0.5, then we could say that the treatments probably affected the output within our level of certainty. In other words, we can reject the null hypothesis, which states that the treatments did not affect the output. If the p-value is greater than alpha, 0.5 in this case, we cannot reject the null hypothesis. So here we go. We can see that light blue has been color-coded to refer to ad text, the rows, and everything associated with them. Yellow is associated with the headlines, the columns, and green is associated with the interaction between the two. And the p-value with each one of those determines what is the answer. We can see the p-value for the rows, the p-value for ad text is 0.7, and that is greater than alpha, so we cannot reject the null hypothesis. In other words, we cannot say for certain that the ad text had an effect on the outcome. The headlines, on the other hand, had a very low p-value, 0.003, and that's much less than alpha. So we can say within 95% probability that those headlines did have an effect on the output. And the interaction, the p-value is 0.2, that's less than the alpha of 0.5. So we can say within 95% certainty that the varying the interaction between the two did have an effect on the click-through rate. So, if you'd like to be an Excel statistical master, take a look at www.excelmasterseries and check out the Excel Statistical Master. That's 4 manuals altogether. It's over 400 pages of MBA level statistics, all explained in Excel for only $19.95. Great bargain. Okay, thank you very much and goodbye.